Okay, now previously we are at hydrostatic force. Again, we have a plate that's submerged under water with a certain angle below the water surface. And we already have some formula to determine or to calculate the FR, the resultant force, acting on the plate here. And we always need to recall what is the equation for pressure. Pressure equal to force divided by area. And we rearrange the equation. We take the force times force equal to pressure times the area. And then there are some cases if we there are some cases where we can straight away use gauge pressure in our analysis, yeah. Especially when it comes to net forces on the surface. We can straight away use gauge pressure. And then we have also covered how to find the location for the resultant force. Where is your y prime and x prime? Y prime, x prime will give you the location of your resultant force. Why this location is important? Because this FR, the resultant force, will create a moment on the from the origin here. So this FR will have a moment that you'll have a moment effect under the existence of FR. And again, FR created because of the pressure, right? Or the water pressure on the surface. So again, there are some typo error in our previous slides. So the error is over here. So if you, the second last two line, so if you take your pressure, the P equal to P0 plus rho GH. So if you take your P times A, you'll get force. So there's some typo error here. They shouldn't have an A here, yeah? So we need to remove the A from our previous slides here. So there's a correction in the slides for FY. So again, we need to remove the A in these slides. There's no A there. So at the end, we will have our y prime equation. Again, we have two y prime equation. One is for when you're considering the ambient pressure. The lower left here is for when we ignore the effect of our P0, which is our reference pressure or ambient pressure. Okay. And also yesterday or our previous lecture, we stopped at the x prime. And also there are some typo error in our slides, especially when it comes to these slides. So here you will see that our P equal to P0 plus rho GH. If you take your P component times the A, you get the force. So again, there's a correction on the slides here. So you need to remove the A from the slide. So there's a typo error when we derive the equation. And here also, yeah, just a reminder, there's no A here. For x bar and x prime, here also we have two scenarios. One, when we consider the ambient pressure, P0, and one equation when we ignore the ambient pressure scenario. Okay, so then today we're going to look at a few examples when you apply the equation. All right, so the example that we're looking at will be the same as your hands-out or your tutorial for chapter 2, question 17. All right, so let's say you have a water and the water is acting some pressure on a surface over here. So this surface have a length of 4 meters and the angle is 30 degrees. And point A here is a hinge, where this one can hinge means something can move. So this plate can be moving. And the height of the water from the surface to point A is 2 meters. Right? So we have an inclined surface, yes, as shown, and hinge at HA, which is we have a hinge here. Determine the resultant force of the water and the water and the air on the inclined surface. So you see, we need to calculate the FR of the water and air. So we need to consider the ambient pressure on this plate. Yeah. So again, it's also one of the popular question when it comes to hydrostatic component. So make sure you pay a bit more attention to this kind of question. So first steps, extract out all the information is given. So we have a rectangular gate, which is this one. Yeah. Hinge along A, and the width is 5 meter, meaning if you take the L times the width, you get the area. So be careful on the information given. If you're looking from this location, you'll be seeing this is L, 4 meter. The width will be 5 meter. Okay, so you'll get the area later on in your calculation. Area will be 5 times 4, you get 20 meters square. Okay, need to find the resultant force. What are the steps? So as you can see on the screen here, there are some suggestion of the steps. So we need to focus on the magnitude of our resultant force, Fr, which there will be a force in this direction, Fr. Over here, we need to find the magnitude and also the line of action. So meaning the location of our Fr, meaning we need to find our x prime, y prime. Okay. So we're going to show you two methods. One is called direct integration, and another called algebraic equation or algebra equation. So we're going to show you two, and then in the exam, you choose whichever that you prefer. Both methods also give correct answer, but however, in exam, normally we will state to use which method to use. So normally, you'll be told to use both methods. So section A asks you to use direct integration method to find the answer. Section B will ask you to use algebraic equation to solve. So you need to know these two methods. Yeah. So we go for direct integration method first. The first equation, before you start any question, put in all the relevant equation. Straight away, you'll get 3 marks. For example, if you put P equal to P0 plus rho GH, you'll get 1 mark. Okay. And take note that in this question, our P0 or our ambient pressure act on both sides, which means P0 and P0 also here. Why we can say P0 also acting on this surface? Because when you times the pressure on the top of the plate here, you'll get PO plus rho GH. So later you can cancel these two. So at the end, you only arrive at the pressure of the hydrostatic or hydrostatic pressure. You can calculate only using rho GH. Okay, right. Okay, before we move forward, I have a question to see. Oliver, are you there?
Yes, I'm here.
Okay, what is the equation for pressure? P equal to what?
Force over area.
Okay, put in term of pressure, rho and gravitational and the height of the water. How you put it? P equal to what?
Rho GH.
Rho GH. That is without considering the ambient pressure. If you want to consider with ambient pressure, what is the full equation for pressure?
With the ambient pressure is the y prime equal to yc plus the pressure plus the density times gravitational force with I don't know how to say this.
You don't know what you're saying.
No, I
Right?
wrote the formula down, but I don't know how to explain it.
Okay, so I'm asking, what I'm asking is, what is the formula for pressure? How pressure equal to this one, P0 plus rho GH. This is the one that I'm looking for. This equation is the one that I'm asking. Yeah. So
Okay,
yeah. So the
I was doing a
equation that
different
you give
equation.
me
So
is,
yesterday's one.
yeah. So the formula that you mentioned just now is a little bit further, right? So yeah. So again, this formula is a bonus mark for in the test or in the final exam. It's very important. Yeah. You write this one, you get 3 marks already. Okay. Now we continue. The first equation is P. The second equation is this one, your FR, because you want to find your resultant force. FR equal to PdA. So make sure you know this equation. Also, you write this equation and get 1 mark for this equation. Yeah. It's very easy to score for this module. All right. Now, we need to draw a free body diagram or a force diagram. So we transfer our question diagram into the one that you see on the screen here. So for the left diagram, you need to know that your H is going down. Huh? Your positive H value is going down. And as you go deeper, the pressure is increasing. So on the plate itself, on the middle, this diagram, on the plate itself, you need to draw a rectangular. Okay, how you convert this diagram into this one. Okay, it's important. We call it free body diagram. So they in the test there will be a very specific instruction, ask you to draw the free body diagram of the forces acting on the plate. So this is the diagram that we are looking for. So without this one, you're losing some marks in your answer. Okay, so how do we draw this diagram? First, you draw the horizon of the surface. Then, second one, you draw the rectangular. Draw the rectangular, the line that represent this line. Okay, this line is this line. Yeah? So you draw the horizon. Second, you draw the line that represent the 30-degree. And then you draw a rectangular that connect to the origin or to the hinge in this place. In this case, it is A. Yeah. So you draw a rectangular and then you draw the solid line up to the hinge here. Okay, draw up to the hinge here. You draw the force distribution diagram. So you draw this arrow. Okay, and then you put in the direction, the axis. Okay, so first step, horizon. Second one, you draw the inclined plane for the plate with this D1. Third steps, you draw the forces acting on the plate. Fourth is the axis. You draw the axis. In this case, your Y is in this direction. And then there's a Z direction axis at the A here, at the hinge here. So you have 4 steps here. Okay, so this one will give you around 3 to 4 marks for this free body diagram. So again, just now you already have 2 marks for the equation, and this one you have 3 to 4 marks. So up to this stage, before you solve anything, you already have 5 marks in your hand if you know how to look for the marks in your answer. Okay, so we have already done with the free body diagram. Now we would like to integrate the n component here. N means the distance from the hinge up to the end of the contact surface here. Okay, so we need to integrate. So we use the n term. Okay, in exam, if you draw free body diagram, you can label anything for this term. Yeah, you can label A for this one, and then later you integrate. But try to avoid A because we use A for area. You can use maybe P or maybe something special, maybe N, in this case N, or K also can, right? Try not to overlap what is the what are the not to ever overlap the alphabet that you already use. Okay. Cool. Any question for the free body diagram? You know how to draw?
A little bit not sure.
Little bit not sure.
Yeah, a little bit don't understand.
Okay. Amir, you understand how to draw free body diagram?
Yes, sir.
Okay, so can you explain to Ku how to do? What is the first step?
Okay, the first step we have to draw the incline, the horizontal one, yeah.
This one.
Yeah. After that, the inclined one here to
This
show
one is
the
the second line.
yeah. After that, we have to draw the lines of force acting
Okay,
on
so how do you draw? How you draw the line of force? How you get the shape?
the shape. It must be sorry, it must be
What kind of shape you're seeing here?
it's a triangle.
Yes, you draw a triangular.
Yeah.
Yeah. So then you put in the arrow here. Okay.
After that, we have to draw the axis.
Yeah.
Y,
So the fourth step is what?
the y-axis.
Yes, the y-axis here. You put in the y-axis and the z-axis. Okay. Yeah. So cool. You understand?
Yeah. Now I understand.
Okay. Can you explain one more time? What is the steps of converting the system diagram to the free body diagram? What is the first step?
The first step is the y-axis.
No. What is the first step?
The first step is from the y to the n.
No. Okay, Amir, you repeat one more time. What is the first step?
Okay, the first step we have to draw the horizon one, the horizon
one.
line. Yeah. The second one we have to draw the inclined line, showing the inclined shape. After that, we have to draw the lines of force. It's like a triangle, so it's made of triangle. The fourth step, we have to draw the both axes, y and z.
Okay, cool. You get it?
Means the first step is the horizontal line.
This one. The water level.
Okay. And then the second step is The
What?
second step is a line to the bottom, and then
Inclined plane is an inclined plane. Okay.
inclined plane.
Mm.
And then
Step three.
the third one is the parallel.
Where got parallel? The third one is triangular. Draw this triangular.
Do
Okay.
the triangular, and then the fourth step is the Y to the Z.
Y and Z, not Y to the Z. Y axis and Z axis.
Y and Z axis.
Okay. Yeah. All right. So Oliver, I assume you understand. So I don't
Yes,
want to make Amir to repeat for the third time. Okay. So again, it's important why I spend so many times ask you to draw free body diagram. Okay. I give you hints already for your coming test. Okay. All right. So we have done with the free body diagram. The rest is just application of the equation that we already learned. We get our H. The next step is to get your H. So how you define H? So H means this is your H. So there's an equation of H because our location from here to here, our H, there's a linear increasing factor. So we need to derive the equation. Our H equal to D plus our N sine 30 degree. So it means that at our hinge here, if we increase to the last point of this hinge, then you need to add a factor called this one. You need to add this component. All right, you need to add this component, and this component, this component is called n sine 30 degree. Okay, why n sine 30 degree? Because it's a triangular, and this is the H. This is the H, not H, sorry. This is the D from the surface of the water, and you need to find an equation that define from your A point to the last point here. So let's say how you find the distance of height from the surface to here, because it will, this height will give you the pressure, the hydrostatic pressure on this point. Okay, so this height, how you find the H from here to here, right? You take the D times something here. So how do you find the height of this one? You use the trigonometry equation. Okay, there's an angle here. So this angle is 30 degree. So this is the triangular that we are focusing on. So how to find this height? You use a sine equation, because A to this point, maybe I name it as A to D, name it as D here. So A to D already given is the length of the plate here. So what is the length of the plate? 4 meter. So in diagram, you already have your 4 meter here. Okay, so your opposite and hypotenuse is a sine relationship. So this one is your H times the sine 30 degree. So that's why we will get that equation. That's why we can use this equation. H equal to D plus your N sine 30 degree. So your N is the length of this one. Okay. Right, we continue. And your dA here is the area that the hydrostatic force acting on. This is the A. All right, so this is the total area that we're looking for. All right. So how we find the area of this one? We take the W, which is the width of the plate, times the length of our N here. So dA equal to W dN. And then you substitute everything into the equation. So F equal to PA. pressure times the area. So of course, with the integration sign of your area, then you substitute what is the pressure equation. So again, in this case, why we do not use, we know that P equal to P0 plus rho GH. Why we do not use P0 in here? Okay, why we cancel out the P0 in this equation, and straight away you use rho GH in the equation here? Okay, Oliver, are you able to explain why we do not use the P0 in this case?
No, so can you repeat again?
Okay, we know that just now I asked Ku, right, about P definition. P is the P0 plus rho GH, correct?
Yeah.
Yeah. So we know that our force, resultant force equal to integration of P dA. So when we substitute our equation, this P definition here, when we substitute into here, why in this case we do not use P0 in the equation? Why we do not consider the ambient pressure in this case? Why P0 missing? Or why we ignore the P0? Or ignore? Why we ignore?
Is it because the force acting is on submerged surface?
50% correct. And one more, there's one more point that you need to elaborate on that.
So there's no atmospheric force acting on it?
Yeah, so because on the top surface, the P0 also acting on top surface, there's a P0 ambient pressure also acting on the bottom surface. So that's why, because why? Because the force acting or the pressure acting on the top surface is P0 plus the hydrostatic force, which is rho GH. So when you want to find the total net force on the plate itself, you can cancel this one and this one. Okay, so that's why in our equation here, we don't need to consider P0 in our case. Okay, good, good answer. All right, so that's why you see from P here, we straight away we can use equal to rho GH, and our H here is what we define equal to D plus our N sine 30 degree. So, and then we expand our dA to W dN here. Okay, so when you change the parameter inside the equation, remember to change the limit of your integration from from A change to 0 to L, because you're integrating using your N. Your N is this one, right? This is your N. N is from here to here, right? So your N is from 0 to L. 0 to L.
Yeah.
Yeah, go ahead.
Can you explain again the dA equal WDN?
Which one?
dA equal WDN.
Oh, you mean this one?
Yeah.
You don't understand, or you don't understand this one?
Yeah.
Okay. Okay. You know what is dA?
Yeah. Okay.
dA is what?
It's a derivation of area.
Okay, correct. So we are talking about the area of this plate, right?
Yeah.
Yeah. So if yeah, you understand now, right? So if you look at this surface, so just now we define our L is N.
Yeah, N is
So,
the length. Yeah.
and then our width is here, so you get the area. D is the small n.
Yeah.
So when you integrate here to here, then you get this one.
Yeah.
It just I think you confuse on the notation, on the symbol that we use.
I was confused on the W also.
Yeah. All these are maybe it's a different notation or different presentation of the parameter.
Oh yeah.
Okay. Yeah. So we continue with this example. So the rest is just integration steps. When you integrate and then you pull all the constant value out. For example, your rho is constant, g is constant, your w is constant. So you pull out all the constant value outside, and then you integrate those changing. Okay, so the first term you get is dn plus n squared divided by 2 sine 30 degree, and then integrate L to 0. Okay, now this step to this step, I will leave it to your mathematics lecturer. So I think you already know how to integrate, how to do integration. Okay, so the rest is just mathematics steps. It's nothing linked with the fluid dynamics. Okay, we move forward. So at the end, you will get your resultant force will equal to rho GW dl plus L squared divided by 2 sine 30 degree. So this is the equation for our FR, or resultant force. Okay, we move forward. I think nothing complex here. Okay, the rest is just substitution of your value. So I also do the step for you. You just substitute. So for example, rho for water will be 999 kilogram over meter cube times 9.81. And again, in exam, be careful on the temperature. This example do not state the temperature of the water. So in the coming test, there will be a temperature mentioned. So you need to refer to Appendix A. Water temperature at a certain degree, a certain temperature, give you a certain value. Yeah. So 999 is a standard temperature. So if the temperature do not mention in the question, then you straight away you use 999 kilogram over meter cube for water. Then G again for module or for the degree level, we no longer use 10 meter over second square. For degree level, we start to use 9.81. Yeah, so be careful on the answer. In exam, if you use 10, I will minus some marks from the answer. Meaning there's no accuracy in your answer. We'll use 9.81 for our gravitational acceleration. So the rest is just substitution, and then the unit will be Newton. So this one is just a cancellation of the unit. Cancel of unit, meaning Newton dot second square will be equivalent to kilogram dot meter. Okay, so at the end, the answer that we're looking for is 588 kilonewton. So this is the answer for this method. Okay, any question want to ask me? Anything that you're not sure or are not clear?
Sure, clear.
Okay, good. All right. The rest is the next one is the location. Okay, usually this kind of question you need to solve for the force. The next one you solve for the location. Okay, so again we use this equation, n prime fr equal to integration of n p dA to compute our distance. So you can replace this n with the x or y. Yeah? So we start to rearrange the equation that you see on the screen here, where your n prime equal to 1 over fr with the integration of mu p dA or n p dA. And you start to change the limit of your integration. When we change your dA, again, your dA will be w dn. Remember to change your dA term here. So when you change your dA, remember to change the integration limit. The next one is you further expand the equation where the P equal to rho GH. Again, in this case, you should be able to understand why we do not use the ambient pressure, why we do not include the ambient pressure, P0 in this case. Okay. The rest is just mathematical steps. There's no complicated mathematics here. Only maybe this equation might be seems new to you. So this is the equation for this question. The rest is just, yeah, like what we mentioned, it's just a mathematical steps. So 1 over FR equal to N rho G D plus N sine theta W and D, and then you do the integration. Okay, the rest is just integration. Again, if you have a constant value in the equation, pull them out to the left, and then you do the integration for the remaining parameter. So you have rho GW divided by FR, integrate from 0 to L, N times the D plus N sine 30 degree dN. So you have two integration here. So I'll continue with the calculation. The rest is just substitution. Okay. So from this integration step, you arrive at dn squared divided by 2 plus n power 3 divided by 3 sine 30 degree, and you substitute the L inside there. The next step is just substitute all the answer. Okay. You get your n prime. N prime is the location from the hinge here, the hinge point A here. Okay, it will be 2.2 meter in this case. So this is the reference answer that help you to double check your calculation. Okay, yeah. So this is the location for n hat or n prime. N prime is again n prime. Need to be careful. N prime is what we calculate from the hinge here. It is your A hinge here. Okay, so this is your N prime. Okay, and again, when recall what is your centroid, if you need to calculate the centroid always less than your N prime. Okay. All right, so I think this is quite straightforward. So again, we need to find your x and y, x prime and y prime. So don't stop at a step at n prime, because n prime only start from hinge A here. You need to always back to the origin where you start from the surface of the water. So your y prime will be, you need to take the D. This is you back to the triangular on the left here. So you have your D 30 degree. You need to plus, because just now you find your n prime here. There's one part that is missing, which is here. This is the part that's missing. So you need to calculate the length of this one. So the length of this one, you use trigonometry. You take the sine relationship. You're able to find the question mark length here. So the question mark is, you use the sine. So you take D divided by sine 30 degree plus the n prime, you'll get the distance of y prime from the origin. From the origin of the, or from the surface, you can say, from the surface of the water. Okay. So you substitute all the value, you'll get 6.22 meter is your y prime. So it depends on the question. Sometimes I will ask you find the location of the force measuring from A. If I ask you the location of your resultant force from A, or from hinge, or from a certain location, then if I ask you from A, then straight away you can give me from the surface, calculated from the surface of the plate, it will be 2.22 meter. If the question asks you to give the answer from hinge. So if the question asks you to give the answer in y prime always from origin or from surface.
So if the question only asks for origin, then we do the y prime calculation. If they don't, we just stick with the original value.
Correct. Yeah. So you need to be careful on what kind of answer that the examiner want to test you. Okay. So you have to show I mean what you're calculating, what you're calculating, and then you give the answer that what the examiner want. Then you will score the marks. Okay. The next steps will be finding your x bar or x prime. Same steps for the y prime just now. You change the n prime to x prime now, the equation. And then you rearrange the equation and you substitute. Yeah. So your x prime will be y 1 over fr integrate a w divided by 2 why we have w divided by 2 because our x were acting on the centroid. So centroid will always, if you have a plate, okay, let me draw a plate. This is your y. So this is your x. Yeah. So if you have a plate with x and y axis, again, maybe I'll draw the axis y and x-axis. Yeah. So the distance from here to here is x. The distance from here to here is y. So just now you already find your y prime. Now we want to find our x prime. So x prime will always always at the center of your plate, the x. So you know that the width is from here to here, w. So your x here will be w divided by 2. It's a half of the plate here. So that's why when we calculate the x location in the equation on the screen here, you put as w divided by 2. Okay, this x here is represent centroid location. Okay, and again, you're not sure what is the centroid, refer to the appendix in the Moodle that I already upload. Refer to the appendix that able to help you where is the centroid. Okay, there's a reference inside the Moodle, so go and look for it. So in this case, we are having a rectangular, so replace your centroid location for x with w divided by 2, and then you continue with the calculation. All right, so you have w divided by 2 fr, integrate your p divided by p dA. Okay. And then you know that your integration of p dA equal to fr. This one, integration of a p dA equal to resultant force. So resultant force cancel with resultant force, you'll get w divided by 2. Okay, so again, remind yourself that sometimes you can recycle what you already learned. In this case, you recycle back the FR definition. FR equal to integration of P times dA. So in this case, you cancel. You don't need to calculate the FR value here. Just cancel. So you get W divided by 2. Okay, in this case, you get 2.5 meter. So this is a quite straightforward answer for your X prime. Okay, we will come back with our algebra equation. Before we go for a short break, I will let you know how do we give you marks in a test. Yeah. Okay, so in this case, governing equation, you give 1 marks for the equation. So 1 mark here. Free body diagram will be, it depends on how complex a free body diagram. In this case, because you have 4 steps, I will give you 3 to 4 marks here. So far you accumulate 5 marks already up to this stage. Then after that, let me see. Okay, then after that is your application of what you know. So these small things here will give you 1 marks. You write H equal to what, D equal to what, or sometimes I will help you to find your answer inside these two inside your answer. So if you write this equation, you get 1 mark for this one. So if you do not write this H equal to something, dA equal to something, but you write the equation out like this and you put in the correct bounding condition, in your marking, we will give you 2 marks for the answer for up to this stage. And then integration calculation, 1 marks. So here you have 3 marks already. Okay, 3 marks. And then answer will be 2 marks. Okay, answer will be 2 marks. It's for FR. So 2, 3, 5 marks, 10 marks already. So the first section, if you ask to find FR, the steps that you see on the screen here already accumulate up to 10 marks already. And then for the y prime, x prime, that one there will be another like 4 marks, 4 to 6 marks for each component. So it's very easy to score for this module as long as you know what are the standard steps that you need to find. Again, for this chapter under hydrostatic, you need to find the FR and also x prime and y prime. Okay, I stop the recording.